it states each point on wavefront means let it with this wavefront. AB is a wavefront. So each point, I just took 3 points, A, B, and C. So each point on a wavefront is a source of secondary waves, which add up. Means these are the sources, and these are the sources due to which this wavefront has produced. Fine. Like rays will be in all directions like this. Fine. So each point on the wavefront is a source of this. Each point on a wavefront is a source of secondary waves. Secondary waves like this, A, B, C are the secondary waves, and due to which they produce another wavefront. This principle definitely will ask in your exam 2 marks question. State Huygens principle and what does it, and this and prove laws of reflection or refraction based on Huygens principle. Now, each point on wavefront means A, B, C, all 3 points. These are the sources. Means I just took 3 points as a sources, but there are infinite number of sources which are on a wavefront. So let it be 3 points A, B, C. These are the sources, and these sources will produce another wavefront, that is D and C, A dash, B dash, and C dash. Now, if we take 3 points A dash, B dash, and C dash, now due to these sources, another wavefront will be formed like this. Now write down. This principle is based on 3 assumptions. First is each point like A, B, C. These are the sources of new disturbance. New disturbance means due to these sources, a new wavefront will be formed again. And A dash, B dash, C dash, these are also the sources for the again. If you further draw this, you'll get another wavefront. Don't draw. There is no need to draw this diagram. Fine. Note down the 3 principles. 3 principles on which the following assumptions. First, each source means A, B, and C. Likewise, A dash, B dash, and C dash. Each point on a wavefront acts as a fresh source of new disturbance called secondary waves. This is first point. Second point, the secondary wavelets A, B, C. These are secondary wavelets. They spread in all directions. The secondary wavelets is spread out in all directions with the speed of light in the given medium. Third point, the new wavefront, that is C and D. In this case, this is spherical. Actually, I took an example of spherical wavefront. The new wavefront at any later time, that is C and D, is given by forward envelope of the secondary wavelets at that time. Done?
Yes, sir.
Okay, fine. Naval, what is wavefront?
A continuous locus of all particles of medium which are vibrating in the same phase at any instant.
Nafisa, let me know the two principle on which the ray.
So the first one is rays are perpendicular to wavefront, and the second one is time taken for light to travel from one wavefront to another is same along any ray.
There are only two students, I think, or three.
3.
Matthew,
Yes,
what do
sir.
you mean?
Sorry, sir, I couldn't hear you.
What is Huygens principle?
Okay, so each wavefront is a product of other incident wavefront,
Secondary ray.
secondary wavefronts. Yeah.
Done. Sorry. What do you mean by Naval? Okay, leave it. And remember one thing: the wavefront is always opted in the forward direction. It is not opted in the backward direction because the energy always flows in the forward direction, not in the backward direction. All right. Okay, fine. So wavefront is always opted in the forward direction, not in the backward direction. Remember this thing. Now, laws of reflection. Laws of reflection on the basis of Huygens principle. 2 marks question.
Okay.
Huygens wave theory. Do you know what do you mean wave theory? According to Huygens, light is a longitudinal wave and it needs a material medium for its propagation and it shows wave character. Wave character means it's basically light is a radiation. That's it. Just a minute. Write down the topic name. Draw. Done.
Yes, sir.
Yeah, just come in a minute. Okay, fine. Now we have to prove laws of reflection on the basis of Heisenberg wave theory. Fine. These two are incident rays. And these are reflected. This is a mirror or polished surface, you can say. Fine. The wavefront which is obtained by incident rays is known as incident wavefront, and the wavefront which is obtained by the reflected wavefront, reflected rays, is known as reflected wavefront. Now we have to show I equals to R, the first law. So how do we show it? Let it be in triangle. We will consider two triangle A, B, C, and triangle D, C, B. First of all, this is an angle of incidence. This is angle of refraction. N1 and N2 both are normal. Fine. If it is angle I, then as I told you, the rays are always perpendicular to the wavefront. So if it is angle I, then it would be 90 minus I, because the entire angle will be 90, and N1 must be perpendicular to this polished surface. If it is 90 minus I and the entire is 90, then it would be I. All right. Likewise, this is R also. So in triangle ABC and triangle DCB, we have to take two triangles and we have to show them. We have to show both of them are congruent. So angle BAC equals to angle CDB. DCDB, because 90 degree, as I told you, rays are perpendicular to the given wavefront, and BC equals to BC, common. And the third one, angle triangle this, and the third, we need one more thing. Okay, as I told you, the time taken by the ray to travel from one wavefront to another wavefront is same. So AC must be equals to BD, that is equals to speed into time. Now, one angle is 90 degree, there is an hypotenuse and side. So by RHS, triangle ABC congruent to triangle DCB. So I equals to CPCT. Do you know what do you mean CPCT? Naval, what do you mean?
Congruent paths of a congruent triangle.
Note down, important. The first law we proved, angle I equals to angle R.
Yes.
Okay, fine. The second law, normal, incident ray, and the reflected ray all lie in the same plane. Fine. Done. Shall I move further? Now the second topic is refraction on the basis of wave theory. Now we have to show Snell's law. Sin I equals to. Do you know what is Snell's law? Naval. Am I audible? Nafisa, what is Snell's law? What is Snell's law, Nafisa? Matthew, what is Snell's law?
So sin I by sin r is equal to n2 1 or like n2 by n1.
Now, now, this is a rarer medium, this is a denser medium. I think you know when a light travels from rarer medium to denser medium, then light bends towards the normal. So this is the angle of incidence. Like as I told you in case of reflection, how it is I and how it is R. So the way is completely same as I told you in case of reflection. Now the speed, I think everyone is familiar that if a light travels, the speed of light changes when it travels from one medium to another. So let it be in the rarer medium, the velocity is v1, and the velocity of the light in the denser medium is v2. So this is v1 and this is v2. So Snell's law, sin I over sin R. We have to show, let it be the refractive index mu1 and this is the refractive index mu2. Indirectly, we have to show mu2 over mu1. Now this thing we have to show. Now first of all, we have to find out sin I. What is sin I, Matthew? Oh, sorry, just a minute. I have to mark. And these are wavefronts, all right, A, B, C, and D.
Sin I is the sign of the incident ray. So.
What is sin I? This is perpendicular.
Yes.
So BC over AC. And what is sin R? Nafisa, what is sin R? AC over, sorry, AD over AC. All right. Matthew, done?
Yes, sir.
Okay, draw this.
Yes.
Note down everything in your notebook. Done?
Yes, sir.
Okay. We'll keep for just 1 hour, all right. We'll complete this section. Okay, now divide. Sin over, sin I over sin R. It would be equals to BC over AD. All right. Is it okay with everyone?
Yes, sir.
Yes, sir.
Yes.
EC basically it's a distance. What is distance? V1 into T and all right. Now just remember one thing. This is equals to mu2 over mu1. This is the relation between the velocity and the refractive index. So we proved sin over sin R equals to refractive index of 2 with respect to 1. Just a minute. Note down. Now we prove Snell's law. This is Snell's law. Note down. Matthew, am I audible?
Yes, sir.
Okay. Nafisa,
Yes, sir.
fine. So do you have problem till now? Whatever I taught you so far.
No,
No, sir.
Revision. What is Naval? What do you mean wavefront?
it is a continuous locus of all particles.
Matthew, what do you mean by Huygens principle?
Every single in a wave is a product of secondary wavefronts.
Very important. Two principle, Naval. Two principle of rays.
First one is rays are perpendicular to the wavefront, and the second is the time taken for the light to travel from one wavefront to the other is same as any ray.
Next. Why does wavefront always obtain in forward direction? Nafisa. Nafisa. Why does wavefront always forward in the forward direction, not in the backward direction? But why? Because energy always flows in the forward direction. All right.
Yes, sir. Okay.
What is the source of secondary? Sorry. What is the source of spherical wavefront, Matthew?
A point charge. Sorry, a point.
Plane wavefront, Naval.
Sorry,
What is the source of plane wavefront?
any point on the wavefront?
A point source lies at infinity, very large distance. Okay, then the wavefront will be obtained like this. Okay, then we will continue on Thursday. All right, at the same time we will meet. All right.
Okay, sir.
Okay, sir.
Thank you, sir.